Hello and welcome. In this lecture, we're going to be introducing member functions and this getSafeNormal function that will allow us to get hold of the direction of a particular vector. Let's dive in and see how this works. So our simple method for sending the platform back in the opposite direction is working at the speeds we've tested it out at. But what happens if I say, hey, let's make this platform go 10 times faster? Let's go ahead and play, see what happens. Well, suddenly that platform's jumped forward quite a lot and it's not hovering around the same location as it was before. And the reason for this is because the current location, when we set it as the start location, isn't necessarily exactly the distance moved. We could have overshot, and that is captured here in the if statement. We're saying that the distance moved is greater than the move distance, which means that we will have overshot. We have to have overshot in order to have triggered this if statement. But the question is by how much? And that's going to depend very much on how large the delta time is. We can overshoot by quite large amounts, especially if the platform velocity is large, which means that our start location may drift over time. It may not stay constant. So the better way to do this would be to calculate how far we need to move from the original start location to get to the new one using the exact move distance. So let's try and visualize this back and forth calculation. We're saying we've got a platform at its start location over here. We say it's got a velocity, which we can represent with an arrow that is a direction and a size. And it's also got a distance that we want it to move. We'll just represent it by this brace here. Now, what we're saying is we would like to figure out the exact point where the platform would be at the end, not overshot, but just exactly the end location. Now, the way we can do this is by taking the direction of that velocity arrow. So in vector parlance, this is called the normal of the arrow, and it basically takes it down to being of size 1. So we get the direction, but a size of 1. So that allows us to know discount essentially the size of the velocity, how fast we're going. And then what we can do is we can multiply that direction by the quantity of our distance to give us an arrow that gives us the whole movement from the start location right to the end location exactly. So let's have a look at how we can do this in C++. What we're looking for is a new start location. So let's remove how we're currently doing this, and we're going to have a start location equal to. Well, what is it going to be equal to? Well, it's going to be equal to, first of all, the start location plus something, because we're starting from here and we're adding this green vector to get to the end. So what's that green vector there? Well, that's where we need to get the normal of the platform velocity. And just to make it easier for us to understand, I'm going to split that into its own variable. So we're going to create a new variable of type fvector, which I am going to call the move direction, just to make it super clear what it is that we're trying to store in it. And then we're going to get this from the platform velocity dot get safe normal, and then some parentheses around the end. So what's going on here? We haven't seen this before. We've used dot to get hold of the components of a vector, the x, y, and z. Those were variables. But in C++ and in object-oriented programming in general, we also have functions that exist on classes. So we can use the dot operator to get hold of one of those. We've used the colon when we've been trying to get it out of the class itself. But when we want to do an operation with the actual vector itself, so platform velocities vector, we can use the dot operator to get the normal of that vector. So that's what we're doing here using a member function instead of a member variable. So we've got the safe normal of that platform velocity, and we'll put semicolon at the end of the line because here we've got a variable that's essentially, we're saying that's the move direction. So now we can use that in the subsequent line to do a move direction multiplied by the move distance that's configured, because we want to move exactly to the end, not overshoot. And then after we've done that, we should actually move our platform to the end location. So we're going to do a set actor location to be the start location, because otherwise our platform will have overshot and gone past that end location because we'll have updated it with the current location, which is the overshot location. So that allows us to move exactly to the endpoint and then start from that new starting location. Now, it's important that we update the platform velocity after we do all of this because we're using it to get hold of the move direction. So I'm going to update the platform velocity after we set the actor location. Now, let's go back into Unreal and hit compile and see if this has fixed the problem with our platform moving backwards and forwards. Let's close down this terminal and hit play. And now if we have a look, the platform's moving quickly, but it is moving reliably around the start and end location we would expect. So that's all I wanted to cover in this lecture. We just corrected a little bit of a bug that could have cropped up for some of our platform configurations. I'll see you in the next one.